binary logistic regression with binary and continuous predictor in STATA. Binary or binomial logistic regression is a statistical method that can be performed when there are two variables. One of the variable, which is the outcome, should have in it categories or levels, and only two levels. That's why it's called binary or binomial. And this variable or outcome variable that have two levels in it, an example for that is whether a person have a disease or no disease, whether dead or alive, whether a person is a male or a female. So the binary logistic regression is performed when the outcome variable is binary and the predictor can be binary or it can be continuous. And the binary predictor again have two levels in it, such as sex, male or females, and continuous predictor such as height, weight, age, and so on. So the aims of the binary logistic regression is to find out whether there is a relationship or an association between a predictor that is binary or continuous and an outcome. Here in this STATA data view, I have three variables. The first one, which is the sex or the gender, and it has females and males, and females are assigned a value of 0 and males are assigned a value of 1, and another variable which is continuous. So the sex variable is binomial or dichotomous variable. The age variable is a continuous variable measured at a scale of year or years, and a third variable which is a disease, heart disease, and this is a binary variable that can either be 0 or 1. 0 stands for no diseases and 1 is assigned for having the disease. So the outcome here is the heart diseases, and the predictors are 1 which is a binary, the sex, and 1 which is a continuous, which is the age. And to find out whether there is an association between sex or age with the outcome, which is heart disease, then the binary logistic regression will be performed. Before performing the logistic regression, let's do some descriptive statistics. In the command section, type sum and then the age variable and hit enter. The variable have a minimum value of 18 and a maximum of 94. So one of the participants, the youngest, is 18 years old and the oldest is 94 years old. And to do the same for the 6 variable, type tab HD for heart disease, and then the 6 variable, comma COL for column, hit enter. 2 by 2 table is generated showing that 97.9% of the males have HD, heart diseases, and 17.4 of the females have the heart diseases. To do the logistic regression, binary logistic regression, type in the command section logistic space, then the outcome, which is heart disease, space, then the first predictor, which is the 6 and it is binary predictor, space, then the continuous predictor, which is the age, hit enter. A table is generated as shown here, showing that the number of observation is 94, and from the table there are three important values to look at: the odds ratio, the p-value, and the 95% confidence interval. Constant value here is given. The table shows the analysis for the two predictor with the heart diseases. So on the left hand side here is the heart diseases, which is the outcome, and the first predictor, which is the gender, and the second one, which is the age. For the 6 predictor, the females have been assigned as a reference category. So for the 6, males are compared to females, and the odds ratio shows that males have 18.9 times odds ratio of developing heart diseases compared to females. Controlling for the effect of age, and this odds ratio is significant as the p-value is less than 0.05. Another way of stating the interpretation is that males have 1792% higher chances of having heart diseases compared to females. This observation also confirmed statistically significant by the 95% confidence interval, as the lower value is 1.4 and the upper value is 241.9. So this range does not cross the value of 1, or doesn't contain the value of 1, and the odds ratio for the 6 variable lies between these two values, and this adds an additional confirmation that these observations are significant. Looking at the second predictor, which is the age, it shows that for every unit of increase of the age, which is 1 year, there is an increase of 1.1 in the odds ratio, adjusted for any confounding effect of sex. This increase is statistically significant as the p-value is less than 0.05. Or in another way, with every year of increase in age, there is an increase of 11.9% chance of developing heart diseases, and this observation is significant as it is again confirmed by the 95% confidence interval, and the odds ratio of 1.11 falls between the lower value and the upper value, and the confidence interval ranges or values does not contain the one value. So this adds an additional confirmation that these observations are significant. So from this table, it clearly states that there is association between sex and developing heart diseases, and between age and developing heart diseases, and males have a higher odds of developing heart diseases, and individual with older age have increased odds of developing heart diseases. So this is the way to perform binary logistic regression with two predictors. One of them is binary and the other one is continuous in STATA.